Alright, Titans of Space. Start off at home, and you have an idea of the sun right here. And if you're running it in stereoscopic mode, which is selected by default, I mean it's the only thing you should ever do with the Oculus Rift is run in stereoscopic mode, you already get an idea of what an object of overwhelming scale is and what it does to the human brain. Now there's going to be an interesting fact coming up about the sun I'm looking at right now, along with the Earth. So I'm going to go ahead and press enter. And this is a miniature of Earth. It should appear to be 12.7 meters wide. So everything right now that I see is at 1/1000th of its original scale. So the sun right now, which to me looks like a sort of spherical wall because it is so bloody big, is at 1/1000th of its actual scale. And so is the Earth, and so is the Moon, and so is everything else outside the universe, which I'm looking over my shoulder now. This is freaking awesome. This demo, I haven't run it in a while. It's actually blowing my mind away already right now. So I'm going to press enter. And the motion is incredibly smooth. You'd think, you know, for a new VR user, this is too much. This feels great. This actually feels good. When it starts moving, you feel good. What? 4,878 kilometers in diameter. About a third the distance between the Earth and the Sun for Mercury. Volume 0.06 Earths. Smallest planet in the solar system. It is extremely dense though. Extremely dense. It's almost a planetary core at this point because it's just cooking under the sun's heat. Let's take a look at our twin planet, Venus, and you can clearly see from the scale here, it's really well done here. It's almost the same size. It's just not doing so good. It looks sick. It literally looks sick. Diameter 12,104 kilometers. Distance from Sun about 3/4 the way where the Earth is. Volume 0.87 Earths. So it's almost the same density and volume. Hottest planet in the solar system because it doesn't really rotate. Yeah. When you remain in a fixed point, you get an infinite greenhouse effect, and it ends up being 900 degrees Fahrenheit on your surface. Wow, I like this. It really got in close. So 1/1000th the scale. That's quite awesome. Mars, the red planet, diameter 6,792 kilometers, almost exactly half. Wow. Distance from the Sun, 1.52 astronomical units, so about 1.5 times the distance from the Sun that the Earth is. Volume 0.15 Earths. Robotic rovers love this place. Oh yeah. Oh yeah. In fact, if we had any larger of a scale, we'd probably look for them. Yeah, there is one thing that is not represented in this demo, and it's the distance scale. The distance scale is completely different from the 1/1000th size scale. The distance is probably at 1/1,000,000th, if not completely inaccurate. Because obviously if this demo were to use proportional scales for distances, you couldn't even see the planets until you traveled to them. And obviously the demo would require you to move at too great a speed and then make the viewer uncomfortable and so forth. So, Ceres, the largest asteroid and one of our 5 dwarf planets. We are actually going to visit this in 2015. It says it right here. I thought of that before I read it. I'm actually looking forward to this. We've never explored this dwarf planet before, so it's going to be a very interesting visit. It's actually pretty clear. Holy shit. Jupiter, largest planet in the solar system, distance from Sun, about 5 times where the Earth is, 5.2 astronomical units. Volume 1,321 Earths. This is 1/1000th the scale. If this were to be in front of me at about the distance I am right now, it probably look like a wall of gas. Kind of like the sun looked like at the beginning of this demo. The 4 Galilean moons are shown here. See them very well. I've seen these often in my telescope. They're very, very, very visible. As soon as you put your eye in the telescope, you see these guys around Jupiter. Jupiter looks like its own tiny little solar system. That is awesome. Callisto, 4,820 kilometers. Most suitable place for human base near Jupiter, because you wouldn't radiate to death. I know the surface looks like crap, and it would be like probably an extremely desolate home. And Io is a little larger. That's interesting. Io is not a place you want to go. Radiation would kill you rather quickly, even with the best of spacesuits, the best of protection. Io would have Jupiter basically kicking your ass without touching you. Most geologically active object in the solar system has 400 active volcanoes. Europa, smooth surface of water ice, possible ocean under the surface. Attempt no landing there. They actually do want to do it because the ocean would be an interesting thing to explore, so it's a huge prospect for exploration, actually. I would propose the exact opposite. Attempt all possible landings there. Oh! Hey, that is awesome! And that is to 1/1000th the scale. Oh wow, look at that. I just saw the ring of Jupiter pass by as the rings of Saturn were unveiled. This is done with real imagery. This is really what Saturn looks like. If you look into a telescope, you always have that wait a minute moment when you look at Saturn in a telescope, because it just doesn't look real. But it's there. It's real. Distance from Sun, 9.5 astronomical units. We're almost 10 times the distance between the Earth and the Sun right now. Obviously, again, I have to mention, distances are totally not to scale, because the Sun starts looking like an ordinary star when you actually reach Saturn. Obviously, a nice little lineup of the moons. Pan, 32 kilometers wide, walnut-shaped, and Saturn's innermost moon orbits inside Encke Gap, a 325-kilometer wide opening in the ring. Pan's gravity sends ripples hundreds of kilometers into the ring. That is awesome. I actually saw the Cassini imagery of this when it was released, and you can see the ripples. It's pretty awesome. Obviously not in this demo, unless it zooms into it, which it won't. That's okay, I mean, it's a detail. In Enceladus, you can actually see they put the jet that was discovered by Cassini. Mimas, known for resembling the Death Star because of large Herschel crater. That's funny. Enceladus, very bright moon with volcanoes of ice at South Pole, liquid water near surface. That's awesome. Look at the amount of moons that Saturn has. Often overlooked as possible targets for exploration when discussing amongst the amateur space community. We often think of the planets. We often overlook these bodies that can also be visited and also have a lot to say about the history of the solar system. Tethys, mostly made of water ice, like Mimas, also has giant impact crater. Dione, very wispy ice cliffs up to several kilometers high. The largest of Saturn's moons. It's almost as large as Mars. 5,152 kilometers, sorry. Saturn's moons. It is the only known moon with a substantial atmosphere. It has liquid methane lakes, and you can see on the edge, the left edge of Titan, the atmosphere there, the blue glow. That would be the atmosphere. Next customer. I believe we're going to Uranus. 51,118 kilometers. one of two ice giants, has coldest atmosphere in the solar system. As you can see from the rings, it's tilted on its side. Distance from the sun, 19 astronomical units, so that's 19 times the distance between the Earth and the sun. 63 Earths in volume. This is far denser than Jupiter, I believe. 27 known moons and beautiful rings. None of the moons are actually inset into the ring patterns. That's interesting. In both cases, in Saturn's case, and actually in all three cases, Jupiter... no, correction, I think Jupiter would be an exception. The ring is on the outside of the moons. Uranus's moons are not yet well mapped. Wow. Yeah, it's kind of far. I mean, this really looks obvious right now, floating around in space, being taken to these places. These places are freaking impossible to go to. Just keep that in mind. When we go there, the impossible is being achieved. It's literally retarded. It's impossible to go to. Just keep that in mind. When you see a spacecraft visiting a place this distant, the impossible is being pulled off. Yeah, and most people forget that Uranus is also a bearer of pretty distinct rings. If you have a really expensive telescope, a really large one, you know, the kind that when you take out on the field, you need a chiropractor after to recover from using it, you can probably see the rings. Neptune, ice giant number 2. Distance from Sun, 30 astronomical units. Obviously, distance is not being to scale here. Volume, 57 plus Earths. 14 known moons. Has very active weather with highest wind speeds in solar system, 2,100 kilometers per hour, which on Earth would be supersonic, or about Mach 1.5 or something. That's freaking insane. That's nuts. 49,528 kilometers, almost as large as Uranus, but not quite. And there's a ring. Wow. That is awesome. We're going to take a look at Neptune's most known moon, I believe, or are there several objects? No, there's just this one. Triton! Oh, and there's the others. Neptune's largest moon by far, captured by Neptune from Kuiper belt as Neptune migrated outward. Frozen nitrogen surface has nitrogen freaking geysers. Not your best place to vacation. It does look like from this imagery that there is a thin atmosphere on this thing. So you can get an idea. Pluto is a tiny speck. 2,306 kilometers. Charon is almost half its size, is actually greater than half its size. Wow. Eris, which was discovered far later than Pluto, is 2,326 kilometers. So you can get an idea that these things are tiny, and they are far. 2 of our 4 outer dwarf planets shown here. Pluto and its largest moon share an orbit around each other. New Horizons probe getting first look at Pluto in 2015. Yeah, 2015 is going to be an interesting year for planetary exploration, with Ceres being visited by the Dawn spacecraft and Pluto being visited by the New Horizons spacecraft. You want to talk about the impossible being achieved? You better follow the Pluto flyby mission live. That will be the impossible getting achieved right there. And I'm telling you, because I don't want to get my hopes too high, I'm expecting a failure. Not that I don't trust the people working on it, because it's such a freaking difficult achievement that, I mean, right now, I can't fathom it working, so it's going to be awesome to follow, because normally all these scientists will do, and these engineers, they're going to surprise you. The Sky Crane was insane on Mars. Wait till you see New Horizons flying by Pluto, the impossible getting achieved. Eris obviously is way further out than Pluto. The distances are totally not to scale. Sun, our own star, volume 1.3 million Earths, age 4.57 billion years, power output 100 billion H-bombs per second. The sun is not fire the way you'd know it on Earth. The sun is actually a perpetual nuclear reaction. What happened for its formation is that basically hydrogen accumulated and accumulated until it formed a cloud out of its own gravity, started collapsing, eventually reaching a mass that allows it to fall into hydrostatic equilibrium. This would be, Jupiter would basically be an a sort of halfway look at the transition, whereas it sort of reaches that spherical shape on its own gravity. But the sun went beyond that, and the gravity exceeded a certain threshold, at which point it causes the hydrogen to start performing perpetual nuclear reactions because the gravity is crushing it so hard. So on its own gravity, collapsing in on itself, it begins basically having nuclear reactions constantly all over the place. It's like a bathtub of nuclear reactions in the shape of a sphere that is in hydrostatic equilibrium. So the sun is not fire as you would know it, which is why the energy is so great. If this were just fire, it would not be strong. It would not warm the planets. It would not hold the solar system together. This is where I mentioned at the beginning of this demo that the theme of this demo is scale. And this, I am far from Pollux right now, even though the distances are not to scale. The sun is in between me and Pollux, and the sun is to 1/1000th of a scale. So is Pollux, with its 12 million kilometers in diameter, if I'm not mistaken. Volume 2,854 suns, power output 43 suns, age 724 million years, distance from the sun 33.8 light years. Why is this star younger? Larger stars are known to live far less time, because think about it, the gravity pushes beyond a certain threshold that is acceptable, and that nuclear reaction goes into overdrive, and the star collapses in on itself at a far younger age. So all larger stars are inherently younger. Holy crap. That is close, that is close, that is close. My mind, this is what I like so much about this demo. You can only do this in virtual reality or by going right next to the freaking star to see an object this big. The impression of scale is mind-ripping. Pollux is confirmed to have a planet orbiting it. That planet is 2.3 times the size of Jupiter. But wait. She ain't the largest one. Holy crap. Rigel, 103 million freaking kilometers. It's disconcerting. And at this point, although the distances are not to scale and the sizes are, these distances that I'm traveling, hopping between these objects right now are huge, because Pollux suddenly looks freaking small, and it's still exactly at 1/1000th of its scale. Rigel, blue-white supergiant, brightest star in constellation Orion. The one that has basically looks like a box with 3 stars going through the middle. Volume 1.7 million suns. Power output 126,000 suns. Age 8 million years. Distance from the sun 860 light years. Again, about age. She's too big to live long. She's too big to hold together. Obviously, this also explains the differences in color. The density is far greater. Oh, hi. There's 2 billion kilometers for you. You see the sun back there? Don't you feel puny now? I cannot see the Earth anymore. I see like specks that are shining. I guess those are the sun's planets. I cannot see any of the sun's planets distinctively anymore. VY Canis Majoris, red hypergiant, largest known star in our galaxy. Volume 12 billion suns. Power output 270,000 suns. Age 10 million years. She's gonna blow. Distance from the sun 3,840 light years. That's kind of close. VY Canis Majoris is nearing the end of its life and is expected to explode in the next 100,000 years, which to a star is like 20 minutes, leaving behind a black hole. No shit, Sherlock. Oh boy, here we go. Here we go. We'll flag all these If you are living on a planet that orbits this star, your people think that the universe is a wall of hydrogen on one side and the universe on the other. There is no universe on this side. There's just a wall of fucking hydrogen. And if they were to express the distances right now at scale, I am really far from this object, even though it's at 1/1000th of its scale. Oh, man. You just need to be on a planet that orbits a star that orbits this fucking thing. Holy crap. You feel small yet? This is a wall. It's barely spherical. This is like standing on the surface of freaking Earth. There is the entire, like, again, the distances are not to scale, but the sizes are. The whole solar system is fit between me and this thing, and it still looks like I'm standing on its freaking surface. The idea of scale in this demo is absolutely awesome. It's mind-boggling. You can't do this without actually physically nearing these objects or using virtual reality. This is really a super functional aspect of virtual reality. Are we going? Yo, yes! Look at that! We're going for real scale distances. Now suddenly the distances have been shifted to true scale. You can barely see the planets as they fly by. Look at that. Earth's actual orbit. There we go. 149 million kilometers. Yeah, that's it. One astronomical unit. And wow. Again, this idea of scale is just awesome. Pluto. Let's orbit up high, crossing through Neptune's. Pluto is actually not following the flat orbital plane of the sun. It's actually pretty interesting the way it just crosses through and goes, yeah, fuck it, I go where I want. Here's Pollux, placed at the center of our solar system. No harm done, except all life would burn up and planetary orbits would be sent into chaos. So this is Pollux at the center of our solar system. Here's Rigel. If it were placed at the center of our solar system, it would immediately engulf Mercury, and within a mass of 18 suns, would quickly draw all planets into the star. All planets into the star. That includes you, buddy. Finally, if VY Canis Majoris were placed at the center of our solar system, the star would likely reach as far as Saturn. Oh no, I've lost control! Yeah, the ending is so like... Okay, fuck it. it's funny. But this demo is awesome, and I recommend anyone who's new to the Oculus Rift to try it before they move on to the more complex things. These demos are great. The motion feels awesome. The guys who did this obviously took in consideration a comfort factor, making it very high level. So that's it. Thanks for playing Titans of Space. Hope you enjoyed your tour. I did, and I hope you enjoyed this review of the tour. That's it. I'm done with this demo. Peace out.